Hi everyone. Today I brought a question from the topic of kinematics, and in this question we have to find the displacement and distance covered in a given interval of time with the help of velocity time graph. Now this question was asked by one of my subscribers, so let me answer the question. So the question given is, here is your velocity time graph. So the graph is parabola and it has concave upwards, not downwards, and they want distance and displacement in the interval 0 to 3 seconds. Now, how do you find displacement from velocity time graph? Well, we need to find the area under Vt graph. Now, if your velocity time graph was like this, then to find the area under the Vt graph, this area would be quite simple. It is just half into base into height, and that area would be the displacement. In this case, since velocity is negative, area of the Vt graph, which means displacement, would be negative. So here it would be quite easy, right? But here this area under the Vt graph or this area cannot be found directly from any standard formula, because this area is neither a triangle or it doesn't look like a square or a semicircle, right? So how do we find the area under this graph? Well, we need to use integration, but to do integration we need velocity as a function of time. So they have not given you any function, right? They have not given formula for velocity in terms of time. So how will you integrate? So the first thing is, from the Vt graph we have to find the formula for V in terms of t. So that's the first thing we should do. Now from this Vt graph, how to find formula for velocity in terms of time? So first method 1, let me describe. Now since it is parabola, it will be a quadratic equation of velocity in terms of time. So let us write one general equation. V equals to at square plus bt plus c. So this is a standard quadratic equation, right? So this is how I will assume velocity changes with time. But we need to know these constants a, b and c. So how to find these constants? Well, from the graph itself. How? Look at this point. What is the coordinates of this point? So at t equal to 0, v is also 0 because the graph starts from origin. So use this condition here. What will you get? So v is 0 when t is 0. 0 into a will be 0, 0 into b 0 plus c. Therefore c is also 0, right? So what will be this equation now? V equals to at square plus bt. So now we have to find a and b. How to do that? Well, look at this point. This is what is called the vertex. Okay. So here when t is 1, v is minus 3. So when t is 1 seconds, velocity is given minus 3 meter per second. Units are obviously known, so I will not put the units. So substitute this here. So when v is minus 3, t is 1, right? So 1 square plus b into 1. So this will give you a plus b equals to minus 3. So this is one equation. Now you need one more equation, right? So you need one more point. So you can use this point. What this point says? At t equals to 2, what is v? 0, right? Because this point is on x-axis, so y coordinate should be 0. So at this point t is 2, v is 0. So put this condition in this equation. So v is 0 when t is 2. So 2 square will be 4, b into 2. So if I take it this side, I will get 2b is equals to minus 4a. Isn't it? So from here, b will be minus 2a. So this b value I will substitute here, right? So then if I substitute b value here, what will I get? So b is minus 2a equals to minus 3. A minus 2a minus a. Minus minus cancel, so a will be 3. And once I found a is 3, if I put it back here, what will be b? Minus 2 into 3 will be minus 6. So I found a and b both. So what will be my velocity formula in terms of t? A is 3, b is minus 6. So this is the formula for velocity in terms of time, right? Another method to find the equation of this parabola, if you know the graph, is if you know the coordinates of the vertex. So if the coordinates of vertex is h comma k, then the equation of parabola is y is equals to a x minus h square plus k. Okay, so here the coordinates of the vertex is how much? 1 comma minus 3. So 1 is your h and minus 3 is your k. So substitute, y will be a x minus h. What is h? 1. K is minus 3. So this will become, this plus will become minus. Now how to find this a? Well, choose any one coordinate in the graph. Let us choose this point 0 comma 0. So when x is 0, y is 0. Right? Let us use this in this equation. So y is 0, x is 0, minus 3. So 0 will be, this will be minus 1 square will be plus 1, a minus 3. So a will be 3, right? So the equation will be y is equals to 3 x minus 1 square minus 3. Okay. Now remember, this was the equation which we derived before. Now I need to show you that this will also give you the same equation. Check now. Of course, y coordinate here means velocity and x coordinate here means t, right? Open this bracket. So a square plus b square minus 2ab minus 3, right? And that will give you 3t square plus 3 minus 6t minus t plus t cancels, and you get the same equation. So if you know the vertex coordinates and coordinate of any one point in the graph, then you can directly use this formula, or you can do the way I told you in method 1. Okay. Now once we found the velocity, we can find the displacement by calculating area under the VT graph. So let us first calculate area from 0 to 2, because here the area is negative, right? So first I will calculate displacement from 0 to 2 seconds. Let me call that displacement S1. So that will be integral v dt from 0 to 2. Integral 0 to 2, v is given 3t square minus 6t dt, right? Let's do the integral directly. 3 will come outside. Integral of t square will be what? T cube by 3, put upper limit, 2 cube by 3 minus 6. Integral of t dt will be what? T square by 2, put upper limit, 2 square by 2. I didn't put the lower limit because lower limit is 0. So there's no point putting the lower limit, right? So this will come, 3 will cancel, 8 minus 1, 2 will cancel, 12. So this will give you minus 4 meters, right? It's negative because it has to be negative, because the velocity in this interval is negative. So particle is coming this side. So displacement should be negative. Okay. Now let me calculate area under the graph from 2 to 3 seconds. Okay. Meaning displacement from 2 to 3 seconds. So now I want from t equal to 2 to t equal to 3 seconds. So the integration has to go from 2 to 3, and that displacement, let me call it S2. So this area under the graph I said is S1, which I found minus 4 meters this side. Okay. And this area I am going to call S2, which we will calculate now. So this will be from 2 to 3, right? S2. So let's do this integration. So H2 will be 3 will come outside, integral t square will be t cube by 3, put upper limit 3 cube by 3 minus 2 cube by 3. Okay, this time you have to put lower limit also, it's not 0. Minus 6 will come outside, integral t dt, that will be t square by 2, put upper limit 3 square by 2 minus 2 square by 2, right? If you take here LCM 3, that 3 and this 3 will cancel, you will get 3 cube, which is 27 minus 8 minus 6. This 2 LCM here will be 2, and this will be 9 minus 4, 5. This will be 2 3s are 6, right? And this will be 27 minus 8, 17 minus 8 will be 9, so 1, 19 minus 15, that will be 4 meters, isn't it? So displacement here is plus 4 meters. It has to be plus because the area here is positive. So now if they ask distance, then you know that if something goes 2 meter this way, 2 meter this way, distance will be what? 4 meter, right? We have to take magnitude of displacement, meaning modulus. So from 0 to 2 seconds, the distance covered is modulus of displacement, and from 2 to 3 seconds, the distance is modulus of displacement. And we have to add. That will give you, what was the displacement here? Minus 4, modulus will be 4. So 4 plus 4, 8 meters. So distance is 8 meters. Displacement will be S1 plus S2, and that will be minus 4 plus 4, that will be 0. Meaning the particle is back to the same point, and therefore the displacement is coming 0, right?